Hello everyone, I'm Sam Strider here for humanHardDrive, and today on Electronics 101 we're going to be talking about batteries. Now, this was a viewer submitted request, and I will give you a little heads up that this is a little chemistry heavy, so I've written this so it's as light in chemistry as I could make it. Now, what is a battery? A battery is a device, quite simply put, that converts chemical energy into electrical energy. And your very basic battery is comprised of two half cells. One half cell is comprised of some sort of container, and in it is a metal, and then that metal is submerged in an electrolyte. And what that electrolyte's job is, this is the, that should be an arrow, there we go. This is the electrode. And here is the electrolyte. And what happens when you submerge the electrode in the electrolyte is it forms one of two chemical reactions. So this is one half cell, and you combine that with another half cell. In it is an electrode submerged in an electrolyte. Electrolyte. So you've got two half cells that makes one full battery cell. And what happens is these are two different reactions. This one on the left is an anion reaction. It's a negative. You can think of it as the negative terminal of the battery. And this is the cation side of the reaction. And you can think of that as the positive side of the battery. Now, in the anion reaction, what happens is when you combine the electrode in the electrolyte, it causes the shed of electrons. So the electrons flow, causing both current flow and electron flow. Now, when you mix the cation, when you submerge the electrode in its electrolyte, what happens is it wants to take on extra electrons. So it's helping the anion reaction to move electrons through to the other side, and that creates current flow. And usually your device is going to sit right here in the middle of this reaction. Here's your voltmeter. And so that's how a battery works. And what's going to happen is, as this reaction occurs, it's going to start eating away the electrodes on either side. And eventually it's going to get to the point where there's no more electrode in the electrolyte, and you've got a dead battery. So that's why batteries die. The other side to this is that you have a rechargeable battery. And a rechargeable battery works in a similar way to the battery in that it discharges. So if I copy this and move it on to the next page, there we go. You can recharge it, and what that does is it creates, in a rechargeable battery, the electrode and the electrolyte exist in a reversible reaction, whereas in, say, a standard battery, this reaction is not reversible. Once the electrolyte has eaten up the electrode, that's it. In a rechargeable battery, I'll label this rechargeable. I can't spell, I know. What happens is, if I remove this voltmeter here, what you can do is you can place in its place a battery. And what that battery can do, move that over there, there we go. What this battery can do is redeposit electrons from where they originally came. So instead of current flow moving this way, you have current flow in the reverse direction. Electrons are now deposited back onto the anion because it's shed away all of its electrons, and it's helping to pull electrons away from the cation side, refilling or emptying that side. And so you can do this repeatedly. Now, the reason these batteries die is, well, the reason rechargeable batteries fail to recharge after a certain amount of time, after certain cycles of recharges, is that the reaction isn't perfect, in that you're destroying the electrode by forcing electrons back onto it and pulling electrons away from it so that it stops working. And you can also overcharge batteries in such a way that you've push too many electrodes back onto the anion, you push too many electrons onto the anion, and you pull too many electrons away from the cation. So that's basically it for how batteries work. So this has been humanHardDrive. Thanks for watching.